Jai Hind to all. My name is Aarti Chaudhary and I'm the assistant professor in IT department from AKGEC Engineering College. So my topic today is infix, prefix and postfix expression. That is our topic in the unit 2, and that one is definitely one question comes from this, that is to evaluate, to convert the infix to postfix or prefix. First of all, we have to go for what is infix function, prefix function and postfix function. Exactly, coming forward, that this is the application of stack. What we are having a stack data structure, data structure we are having. In that data structure we are having having a property of LIFO, that is a last in first out property. So that property is used as an application for infix, prefix and postfix expressions. So this is the application of a data structure, that is a stack. Next, moving, what is a prefix function, postfix function and infix function. Prefix function is also known as Polish, that is reverse Polish notation, and infix notation. I will go for that. These are the three different but equivalent. Three are equivalent, but their way of expression is different. In that, operands are having a same order than but the operator, that is operand, what we are having is A, 5, B, anything that is a we can say it as a any terms that is A, B, C, then numeric type and then the character type. But what are about the operators? Operators, what we are is plus, minus, divide, into, and this is a exponential. Exponential we can write like this also, and we are having a pointed upper point. We are saying like this. Okay. In that operand, there were three notations here. We are having infix also, postfix also, and prefix also. In infix, we are having two operand, and in between them, we have a operator. This is called infix. In between we are having. In the postfix, what we are having, when we have to write all the two operands, and then after we have to write an operator there. And prefixes, before the operand we are having a two data operator, that is plus, and then we are writing that operand. So these are the three notation. In between we are having a infix, the operators are in between. In the postfix it is after that, and in the prefix we are having before that. Okay. Next, what we are having is we have to evaluate the infix notation by making that infix, because for the infix to postfix and prefix it is easier, and there is an algorithm of it. To solve that, we are having a precedence also. We are having these three operators. We have plus, minus, divide, into, and we are having a power operator. So for that we have to be a precedence. There is ambiguity there. Which one is to be evaluate first, which is to be not evaluate first, because in the precedence what we have to do is we have to convert the expression from the infix to prefix or postfix. So for that we have to make that the operator in that order that is given is evaluated, also converted into that prefix or postfix, and the precedence of the operators have to be same in that version, in the infix also and in the conversion also. So that the ambiguity precedence has to be there, as to be making that is to be there. The precedence of the operator is not required in pre and post, so there is a does not have an ambiguity into this. So what we have a precedence. Precedence and associativity. Precedence is highest precedence and lower precedence. For example, we are having an expression A plus B, this C. What we have having this is example. Exponent have a highest precedence, so we have to evaluate this first. The exponent have a highest precedence, and it is a right associativity, that is to be evaluated from right side. If we are having two elements, that is a multiplication and division, this is second highest priority, and that is a associativity left to right we are having. And the addition and subtraction, it is a lower priority, and in this we have a left associativity. So in that, what we have to evaluate first, we have to evaluate the exponent first, that answer will come here, and then after it will, for example, it's a numeric expression, and then have to 2 power 3. So what we have to evaluate first? 2 ki power 3, that is 2 ki power, that is to be 2 ki power 8. 8 plus 5, that is our answer 13. Okay, that's this which we have to done in this. But in the computers, what we are having is to use a stack for these expressions. So we have to go for a precedence and then associativity. The highest precedence has to be exponential, and the lowest is we are having a plus minus. In the middle we have multiplication and division, and this associativity is also there. The right and left, the exponent are evaluated from right associativity, and the plus and minus and in multiply and divide is to be left associativity. Okay, next, comparison of prefix and postfix. Infix is, it is easy to read from prefix and postfix notion, as we know that in the infix we are having, we know that this two operand has to be have a operator plus, and we have to add them. But in a case of prefix and postfix, we don't know a plus b and a plus b minus. We don't know about this. We have to plus first, and then, so we are in the general mathematics also, we are just following this also, we are having a infix expressions. We are not familiar with the prefix and postfix. Infix expression requires additional information to resolve the ambiguity. We are having an ambiguity problem in that. If the operator is of lower precedence and is needed to be applied before, you have to need to put the parenthesis in a postfix expression. So when we have to have an expression, we have to be put two parentheses in the starting and in the end, and then after we can convert that into a postfix expression and the prefix expression. Okay. Next, this is an algorithm to convert the infix to postfix expression. What we have to do is, that if we are having a expression, mark it as x. We are have to mark it any expression that is there, so we have to mark it as an x. Okay, the algorithm will have to find the postfix expression of that y. Before going to the start that, we have to make that, we have to put two parentheses first at the starting and at the end additionally into it. We have to make it. The first we have to encount the first parenthesis, that is starting one, and we have to add that at the end. So at the starting we have n, and at the end we have add it. So we have to make a infix expression, and then we have to convert into a postfix expression. We have to go for a scanning from left to right. This is left and this is right. We have to scan from here to here. What we have to do, and scan up to when the last this is not encountered from the stack, and then after we have to pop it and we will get a regular expression for it. Okay, so we have to scan from left to right, and we have to repeat all these steps from 3 to 6 until we have to pop all the elements. Fine. Okay, if we have operand into which in the expression, infix expression, we have operand, then we have to add in y. Y is an expression for the postfix notation. So if we are having any operand a, b, c, d, 1, 2, 3, 4, anything, we have to be make in a postfix expression. If we encountering a left, then we have to, any left parenthesis is encountered, we have to push into a stack until we get the right parenthesis, because we have to make that possible that we have to have left also and right also. We have to pairing that left is also there, right is also there. If we have an operator there was two condition arises. The first condition is, if we are having a in the precedence also, if we are having any, we are having a into, and then after any element, any operator comes minus. So you know that this is the highest precedence and this is a lower precedence. If this comes into the scenario, we have to pop this, and this will go into our postfix expression. If we are having a higher priority operator, and then upper that there was a lower priority operator, then we have to pop the highest priority, and the lower priority will remain. So the lower priority have minuses remain, and the and what is minus, then this multiplication is going to a postfix expression. There was one case. Other cases, if we are having a lower priority function here and the highest is here, we will not pop. We will not pop there, and we will wait until we will uncount the what? We will uncount our right parenthesis there. If we get a right parenthesis, then we have to pop here and write into our right to left manner. That is, first we have to write this multiplication and then we will write a minus here. So there was two cases here. One, we are having a highest operator there, and there was a lowest operator. We have to pop the higher operator and then push into a postfix expression. If we are having a condition that we are having that we are a lower priority operator and then we are having a higher priority, so that we have to wait until we will get a right parenthesis there. When the bracket is complete, when there be a right parenthesis also, left parenthesis also, then after we will pop and we will write into a right to left manner. We will write a multiplication and then we are having a minus. So this is algorithm about infix to postfix. We'll come across any example. Through that we will make that thing more clear. This one. In with this is the expression that A plus B bracket B into C minus D divide E power F into G this. So first of all, I have said it कि you have to write a right parenthesis and the left parenthesis at the starting. So just add right parenthesis and the left parenthesis at the starting. Okay, this is a symbol. This is the steps we are having. This is a scanning. From right to left, we are going for a scanning, and we are having a stack in which we go for a push and pop. The application of the, because I'm just in the starting also have this is the application of the stack, and this is a postfix expression, that is y, and this is a infix expression, that is equals to x, and this is a description of what we have to do in the method. Fine. First we have to scan. This is a this came here. This is a that is a right left parenthesis. They have to push into a stack. So it's like pushing into a stack until it will come empty. Fine. Next we are having a A. So A will is there. So I have just said that कि operand will push into a expression. So we will write into a expression. So A is encountered, that is a operand. It will push into a expression. Then we are having a plus. Plus, it is a operator. Any other operator? No. Until now we are not having an operator. So plus will go there, and we are having a A. Then there was other bracket coming here. This is a one bracket also, and this also we will push into a stack, because operators are pushed into a stack and operands are coming to it. So I will write it here where we are having an operand, and here we will having a operator. Okay. Then we are having a one left parenthesis also. The will push into a stack, and there was in the expression, postfix expression, we are only having A right now. Next we are having a B. The B we will it's a operand. It will push into a postfix expression. So A and B, and this will remains the same. Next we will have a multiplication. Okay, we will write this, and because it is an operator, we have to push into a stack, and this is mentioned. This is my expression. Then we are having a C. There was only a this. We will push in. We are having a postfix expression, that is by a y we are denoting it. Next we are having a minus. When this will come, a minus will come, there is a priority that it's like this plus into minus. What the case is? This is the highest priority and this is a lowest. So what will be? The highest will pop from the stack and come to the postfix expression. So this will come here, and this is minus here. Only minus. If the lowest is at the down and the if the highest is at the down and the lowest will come, so then the highest will be pop out and then come to a postfix expression. So this will come here and the minus will remaining. Now scanning from left to right, there was a other bracket, opening bracket, then we are having opening bracket, then when D, so D will push into a here, then we are having a divide, we will go for a divide also, any proper way, E, then E will go with here because the operators, operands are going here and the operators are going in a stack. Then what we are having this situation arises as plus, minus, and this and this. What the case is to be? This is a case where we are having a lower and this is called a higher. This situation arises, we will wait until there was a right parenthesis, that is closing parenthesis, and then we will pop it from the stack. So we will save it in like this also. Then we are having a F we are having is to be in the postfix expression. Then this arises, that is closing of it. So then what I in the algorithm I said it, okay, you have to write from right to left, then this will go here and this will go here, and this whole bracket is gone. So this will is in the right to left. In the right to left manner we are making that. The first this is printing in the postfix expression and then this is printing. Okay, then it is going to a postfix expression. Then this is a closing of it. Then there was a multiplication, then the multiplication comes. This is a case where this is a lower and then higher. Wait until the right parenthesis coming. So right parenthesis will come, then after we will go for it. Then G will mention when this right parenthesis came here, this is a situation, then it will push first into and then minus. Okay, then after there is a multiplication, then there is a multiplication, because it's a lower and this is higher, it will not pop up to when we are not having a parenthesis. Then this is a H, so it was a H here, and this is a closing parenthesis, then it will come like this, multiplication and then multiplication. So you will say that this is an infix expression, that is in the between of the operands you are having a operators. But in case of we are converting from the infix to the postfix expression, we are making that after the operand we are having a operators. So we are having a operators there, and they both are equivalent. They both are equivalent. When we have to calculate anything from the infix and the postfix, all the same expression we are having conversion, and then we will get a same result from it because no ambiguity is to be there. Okay, this is our infix to postfix expression. Next we have a infix to prefix. So what we have to do in infix to prefix, you have to make that if we are giving a infix expression. For example, we are having X, so you have to write it then the reverse order. Reverse order is from the right to left, you have to write it, and same thing you have to do in here also. When the left, you are having a same situation where if you are having a highest priority and there was a lower priority, highest and then lowest, then you have to pop the highest and the lowest is remaining here. Second case also same, similar. If you are having a lower priority at the low and the highest priority operator at the high, you will wait until the right parenthesis come, and the right parenthesis will make it a pop, and you have to write in a right to left exercivity. Right to left, that is first of all you have to write this, and then after you have to write the minus here. Okay, this is a thing of it. Then we will go for a question of this is, there was an expression, you have to write it in a reverse order, and then after you will evaluate this function. So I will go for it. This is an expression. This is an expression. So what you have to reverse order is 5 E D. Okay, 5 E D multiplication. Then we are having this C B plus A. You have to write it in a reverse order. 5, this multiplication, then E, and then D, and then plus into, sorry, and then close. It's a making it at reverse. Don't reverse the order of this. This is right. This is right and this is left, because we are having an equivalent parenthesis. Right also, that is right or left, that is for opening and closing, that is to be equivalent. and then after C, B, and then A. We have to write in a reverse order. We have to replace that, and then convert this into a prefix expression. What we have to do is, first of all, we have to make that expression and make that a term that is a single starting and ending of that expression. Fine, we have FT, make it that you have inserted it and we are having it. Then we are having a fine, make it this. Then we are having a 5, we will insert it here. This is a prefix expression and this is our stack and this is a image and this is a y and this is a x. Okay. Then we will insert it because we are having that here we are having the operand and here we are having the operators. Fine. And then we are having this operator that it will inserted here and this is 5. If that E is inserted, the E is 5, E will inserted here, and then after what we have to is plus will come here because the priority is like this, highest and then lowest. What we have to do is pop the highest, so the pop will go here and only the lowest is remaining into a stack. Okay, then we are having a D, so we will go for a D. Then we are having a star, so we will giving a star because it's a lowest and this is highest. No popping will be there, no popping until we are having it. Okay, then we are having a this C, D, C parenthesis comes where we are having a C, we will insert it here. When we are having a power operator, we will insert it into a push into a stack, and then we are having a B. B will be also inserted in our expression. Then we are having a plus. We are having here plus. So this is highest and then lowest. So we have to pop this and this popping will go for our power operator there. Then we are having a A. A is there plus and then we are having a A. So A will go here. And then this expression with closing with this. So we have to write it this what we have to write is, well, we have to write it plus and this is a end. We are having a plus and then multiplication. So that is to be right to left, you have to write it. That is from the right to left. The first we have to write it a star and then plus we are having. So this is the expression for which we have to pop and we are having a empty stacks from it. So in this we are having, first we have to, expression has to be reverse order. Reverse expression we have to write that. Then after the expression, convert expression to postfix by using it and then reverse it. So by, this is not our answer this way. This is not answer. We have to reverse it. So we have to reverse this plus into A plus into A plus, sorry, plus A. This is power operator B, C, D, power E 5. So that is the thing. We are having this and this is our result. Because in the prefix expression, you have to have operator at the starting of operands. So in this, there was a little more case. That is, first we have to reverse the infix expression. By infix expression, you have to convert the infix to the postfix, and the postfix will making that reverse order, and then the prefix will converted it. So we are having a prefix here. This is a whole process of postfix. So we have to convert this infix. You can say it infix. You have to reverse it. In the reverse order you will write it. Then after you will convert it into a postfix expression. This the result is. Then reverse it. And then reverse. We will go for a prefix expression. This is a mention. So all that you have to be one algorithm for the postfix. In that also be you make a brief of algorithm. First you have to insert any operand into a expression. In the operator, you have to push into a stack. There was two cases into it. First case is if you are having a highest priority function operator and then lower priority cover, you have to pop the highest priority and then the operator will go into a expression. Otherwise, if we are having a lower priority operator and then we have to go into a higher priority higher priority order, what we have to do is we have to wait until our right parenthesis came for to making right and then left. Then that expression will be evaluated from right to left. You have to write into a right to left order into a expression. Then we are having an expression of it. Okay, so we are discussed all the two infix to prefix and infix to postfix algorithms for it, and this is and thank you.